drivers escaped serious diagram. So I am cluing you in this problem, but you have to pick up on your own. What about this problem is telling me to make a tree? And the key is that these two percentages are conditional. This is not out of all accidents like this number is. This one is marginal. This is 77% of all accidents the driver was wearing a seatbelt. So that's going to be on our first branch. Our first branch is going to be seatbelt. And the bottom one is always the complement, no seatbelt. This has nothing to do with whether they escape serious injury or not. Okay, those are going to be on our next branches. So if we know 77% of all accidents were wearing seatbelt, then by default 0.23% are not wearing seatbelts. Together these add to 1. And so here we're talking about all accidents. So you don't have to write this out here, but we're talking about all accidents, okay? That's our kind of our marginal. Their second variable has not been included in here yet. Now, 92% of those drivers, and they were referring to here back to the seatbelt wearers. So now, off this branch here, I've got escaped serious injuries. I'm going to call them okay. They were okay. That's 92%. It's not 92% out of all accidents. It's just 92% of the seatbelt wearers. That's why it's off this branch. So if 92% of this group were okay, then 8%, remember these branches here add to 1, were not okay. Or you could write injured, whatever you want to call that. Okay? So we've used this number, we've used this number. Next we need to go to this number. But only 63% of the non-belted, that's this group, no belt, only 63% of this group were so fortunate, meaning they were okay. Only 63% of this group were okay, so my not okay out of my non-seat belt wearers would be 0.37. These have to add to 1. And that's our tree diagram. So these three numbers went here, here, and here. I found these other three numbers going across. So all right, so 0.77 times 0.92 is 0.7084. 0.77 times 0.08, 1. You can double check yourself by making sure these four numbers do in fact add up to 1. Um, 5, 1. So now let's double check. It's a good check there. Caught my mistake. They do in fact add up to 1. And what these probabilities are, this is the probability of seatbelt and okay. This is the probability of seatbelt and not okay. This is the probability of no seatbelt and okay. And this is the probability of no seatbelt and not okay. Question is, find the probability that a driver who was seriously injured, that's a condition. That's a condition. You are now only looking at the people who were seriously injured. What's the probability they were not wearing a seatbelt? Most students think that I'm just basically asking you for this number answer. Okay, that would be out of all the accidents, what was the probability they were not wearing a seatbelt and they were not okay? That's out of all accidents. But this is talking about specific accidents. This is only the accidents where someone was not okay. What's the probability they were not wearing a seatbelt given they were seriously injured, or I called it not okay? So what's the probability of not wearing a belt knowing they were not okay? We have a formula for this. It's no belt divided by no belt and not okay. That formula is on your formula sheet. You do not need to memorize it, although you should eventually probably know it because we're going to use it a lot. Now, the no belt, excuse me, I just wrote that whole formula wrong. Okay, these need to be flip-flopped. My apologies. On your formula sheet, probability of no belt and not okay, that's in the numerator, over the probability of not okay. My bad, sorry. Probability of A given B is the probability of A and B on top, and then just B on bottom. That's my fault. Now, this group is just this guy right here. No belt, no seatbelt, S for seatbelt, not okay. That number, the numerator, is just in the chart. It's the denominator that we need to get from a little bit of math. The not okay group shows up in two places. They are here and they are here. So this needs to be out of everyone who was not okay. So either you were wearing your seatbelt and you were not okay, or you were not wearing your seatbelt and you were not okay. Together, these are all the people who were not okay. So together means add. So I'm going to go to my calculator and type in 0.0851 divided by open parentheses 0.0851 plus 0.06, 58% or 0.58. So that's out of all the people who were seriously injured, over half of them were not wearing their seatbelt. You could, some of you might like the tables. You can make tables instead of tree diagrams if that's something that you're interested in. I can show you real fast where the numbers would go. Remember, you have, these are all accidents. You've got seat belt and no belt, okay? And you have okay and not okay. So once again, we're making that two-way table. Okay, remember this adds to 1. And 77% of all accidents were wearing seatbelts. So that number goes out here, okay? Now these numbers are not in the table because these are conditional. 92% of those drivers, so it's 92% of 77. So you need to do 0.92 times 0.77. 92% of this group escaped serious injury, were okay. So that number goes here. But 63% of the non-belt drivers, which I can figure out is this number, because these have to add to 1. 63% of this group, 0.23 times 0.63, were in that same fortunate scenario. Now you've got enough to start filling in the rest of these squares. Notice that we just did the exact same thing. You just multiplied 0.77 times 0.92. I did that right here. And we just multiplied 0.23 times 0.63, and I did that right here. And then the math will work itself out the same for you to find all the other numbers. So you might like the table better than the tree. Whatever works for you, whatever you see first is what you need to go with. All right, that's it for chapter 14. There's a lot of formulas in here, very mathy, different situations. You do different things for different problems, so you really need to practice it. Please read through what can go wrong and what have we learned in your AP tips for chapter 14.